For this lesson, you're going to need both your Unit 10 notes packet as well as your flip chart. We're going to be bouncing back and forth between both of them, so make sure you have both of them out with you and that you're ready and prepared to take the notes and copy the examples down. So what we're going to start with is zero and negative exponents. And once we go through the lesson and you realize the patterns of zero and negative exponents, it should come pretty easy. So the essential question is, how can you evaluate a non-zero number with an exponent of 0, and how can you evaluate a non-zero number with a negative integer exponent? This might not make a whole lot of sense right now, but just know we're looking at 0 and negative exponents. So if we start with the notes in your packet, it says 0 powers, complete the table. So in the first column, we have a quotient of 5 to the third divided by 5 to the third. So in expanded form, we're going to write that out. So for the numerator, I have 5 to the third. That would be 5 times 5 times 5. That's expanded form. We don't want to actually evaluate what 5 to the third is. And then in the denominator, we have 5 to the third again. So 5 times 5 times 5. Okay, now, simplest form, you might notice something here. When I take a number and divide it by itself, it equals 1. So this 5 divided by 5 for my first two numbers, that equals 1. So I'm going to cross cancel that out. Excuse me, I'm just going to cancel it out because it's 1. And then the other one, 5 divided by 5, is also 1. And our last set, 5 divided by 5, is also 1. So when I look at the top, I have 1 times 1 times 1, which is just 1, and 1 over 1 equals 1. So that's the simplest form. So you might be thinking, how do I get 1 out of 5 to the third? Well, I'm taking 5 to the third and dividing it by itself, 5 to the third. A number divided by itself will always equals 1. Okay, we'll look at the next example, 6 to the second divided by 6 to the second. So in expanded form, the numerator would be 6 times 6, and in the denominator, I would have 6 times 6 again. But then I notice here, oh, if I have 6 divided by 6, that's really 1 whole. So I'm going to simplify that. And the second set, 6 divided by 6 again, is 1 whole. And when I do 1 times 1 divided by 1 times 1, I have 1 over 1. So in simplest form, that equals 1. Okay, so you might be noticing some patterns here that'll be a little bit shorter instead of having to always write it out in expanded form. If we look at the next example, you can visualize negative 3 to the fourth. So you'd be multiplying negative 3 by itself 4 times in the numerator and 4 times in the denominator. Well, what happens is the 4 negative 3's on the top match up and cancel out with the 4 negative 3's on the bottom, so it simplifies to be 1 over 1. So you could write this out in expanded form if you wanted to, which just equals 1 in simplest form. And then the last one, I have negative 4 to the fifth in the numerator, and I'm dividing it by the same thing, negative 4 to the fifth. Okay, so I have the same number on the top as the bottom. When I divide a number by itself, the negative 4 to the fifth on the top, divided by the negative 4 to the fifths on the bottom, simplify to be 1 over 1, which equals 1. So now if I look at some generalization down here, it says if 5 to the third divided by 5 to the third simplifies to be 5 to the 0 power, so we're saying another way to write 5 to the third divided by 5 to the third is just 5 to the 0. If we go look up at our first example, so I could have just written this as 5 to the 0, notice that equaled 1. So what does 5 to the 0 evaluate to equal? 1. Okay, so this is a really unique property. We notice something to the power of 0 equals 1. Next one, if negative 3 to the fourth divided by negative 3 to the fourth simplifies to be negative 3 to the 0. Another way to write that would be negative 3 to the 0. Now look at this example here. Negative 3 to the fourth divided by negative 3 to the fourth is negative 3 to the power of 0. Well, then negative 3 to the power of 0 has to evaluate to equal 1. So to generalize, therefore, any power of 0 will always equal 1. So anything to the power of 0, if the exponent is a 0, it's going to simplify to equal 1. Example 1, I have negative 3 to the power of 0, that equals 1. Example 2, 7 to the power of 0, it equals 1. Example 3, x to the power of 0. Now you might be thinking, we don't know what x equals, but it really doesn't matter. No matter what number I put in for x, it's to the power of 0. And anything to the power of 0 equals 1. Now, example 4, 5, and 6, there's some operations involved here that we have to look at before we take care of the power of zeros. So first one, 4 to the third times 4 to the 0 power. So if I take a look, 4 to the third, 4 times 4 times 4, that gives me 64. So I know this is 64, times 4 to the 0 power. I know 4 to the 0 power is 1. So 64 times 1 is just 64. Okay, example 5. Now there's something you need to notice about this one. This is negative 5y to the 0 power, but really negative 5 is multiplied by y to the 0. So this y to the 0 is the only thing that is to the 0 power. The y is to the 0 power, the negative 5 is not. If it was written like this, negative 5 times y in parentheses, and then to the 0 power, it would apply to both of these factors, but it isn't. So this 0 power only applies to the y. So y to the 0 power, that's 1. And then I'm going to multiply it by the negative 5 out front. Negative 5 times 1 is negative 5. And example 6, probably the most complicated one. I have 3m to the 0 power times 4 to the 0 power x. Okay, so notice m to the 0 power is the only factor that is to the power of 0. So m to the power of 0 is just 1, and I'm going to bring down the 3 out front. 3 times 1 is 3. Then I'm going to look at the next factor, 4 to the 0 power. That's 1. I'm going to bring down multiplying by x. 1 times x I know is just x. And then notice it says I need to multiply these two factors together. So 3 times x is 3x. And so that simplifies to be 3x. The m totally was eliminated because it was to the 0 power, so it just equaled 1. Okay, now we're going to switch gears and we're going to fill out a couple flaps on your flip chart, and we're going to go back and forth. So you're going to want your flip chart and your notes side by side so that you can stay caught up here. So the first one we're going to look at is 0 exponents. You can open that to the blue flap, the first one, and this flip chart will be super handy for you to reference, especially when you get to your final test. So it says any number raised to the power of 0 equals 1. So x to the power of 0 equals 1, even though you don't know what x is. 8 to the power of 0 equals 1. 5 to the power of 0 equals 1. And y to the power of 0 equals 1. Okay, so we're going to go back to our packet here and look at the next section of properties of exponents. Okay, the next property that we're going to look at are negative exponents. And negative exponents are considered to be not simplified. Okay, and they need to be written using positive exponents. So it's just that we don't write exponents with negative exponents. We don't write powers with negative exponents. It's just not the proper form. So we're going to make sure that we know how to change it to the proper form. So it says to make a negative exponent positive, you're going to write the reciprocal. Okay, and if you remember from probably dividing fractions, the reciprocal is just the flip of the power using the positive exponent. So looking at example 1, I have 4 to the negative second power. So this negative 2 for the exponent is not in proper form. So what we're going to do is we're going to take the reciprocal of 4 to the negative second. Now the way it's written, 4 to the negative second, is really over 1. So when I take the reciprocal of it, I'm going to flip the numerator and the denominator. So then the 1 becomes the numerator, and 4 to the negative second becomes the denominator, but the exponent is no longer negative. So it's just 4 to the second power, because that makes it a positive exponent now. So I have 1 over 4 to the second, and I'm going to keep simplifying. I know the numerator is 1, and 4 to the second would be 4 times 4, which is 16. So it's 1/16. Okay, 4 to the negative second, just like in scientific notation, negative exponents make really small numbers. 1/16 is a really small number. Example 2, I have 1 divided by 3 to the negative second. So this is not in proper form with the negative 2 for the exponent. So I'm going to flip, take the reciprocal of the numerator and the denominator. So the 3 to the negative second is now in the numerator, but it's a positive 2. So 3 to the second. And then in the denominator is 1. So these two flipped. Okay, and I'm going to evaluate this. 3 to the second, that would be 3 times 3, which is 9 over 1, and 9 over 1 just equals 9. Okay, example 3. Now there's something you need to notice here. I have negative 5 to the negative third power. So the part that's not proper is this negative 3. The way it's written, remember it's over 1 because all numbers can be written as a fraction with a 1 under it if it's a whole number. So I'm going to take the reciprocal. I'm going to flip the numerator and the denominator. So in the numerator I have 1. Now in the denominator I have negative 5 to the positive third power. So the only part that becomes positive is the exponent, the 3 here. The negative 5 stays negative because that is not part of the exponent. That is the base. So now I need to evaluate on the top, the numerator, I have 1. In the denominator, I need to figure out what is negative 5 to the third power. So I'm going to use my calculator here. Negative 5 times negative 5 times negative 5, which gives me negative 125. Okay, and typically I don't put the negative in the top or the bottom, I put it out front. So this equals negative 1/125th. Okay, and for example 4, again we have negative 2 to the negative fourth power in the denominator. That is not proper. So I'm going to flip the numerator and the denominator. So in the numerator I have negative 2 to the positive fourth. Okay, notice it stayed negative 2. The only part that changes is the negative exponent. In the denominator, I have 1. Okay, and now I'm going to evaluate this. I need to figure out what is negative 2 to the fourth power. So I'll start with negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. And then divided by 1, that's my denominator, 16 divided by 1 is 16. Okay, so you're going to go to your flip chart and to the second tab, the orange one that says negative exponents, and we're going to record some simple information so that you have it to look back on. So negative exponents are not simplified. To simplify, change the sign on the exponent and use the reciprocal, flip it. So the first one has been done for you. It was x to the negative second, and remember that would be over 1. So when I take the reciprocal and I flip it, I end up with 1 over x to the second. And we leave it as x to the second because we don't know the value of x. Next one, I have 5 to the negative third. Remember that's over 1. So I'm going to flip it. The 1 and the 5 to the third are going to switch places. So I have 1 on the top. In the denominator, I have 5 to the positive 3 because my exponent now turns positive after I take the reciprocal. And I can keep evaluating this because I know that on the numerator, I have 1 and 5 to the third. 5 times 5 times 5 is 125. Next one, negative 5 to the negative third. So remember that's over 1. So when I flip it, I have 1 in the numerator. In the denominator, I still have negative 5, but it's to the positive third power. And when I simplify this, in the numerator I have 1. And in the denominator, negative 5 times negative 5 times negative 5 is negative 125. So I put the negative out front instead of keeping it with just the denominator. And then the last one has been done for us. If you start with 1 divided by x to the negative third, you're going to flip that. So x to the third is now in the numerator, and in the denominator would be 1. But when I simplify, it just equals x to the third. Okay, and the last property that we're going to look at today is adding and subtracting with exponents, which this is actually a big review from chapter 1 as well as 7th grade math. So combining like terms. Like terms must have the same variable and the same exponent. Okay, so this is a giant review from chapter 1. If you remember the Zonkies, that's part of those like terms. So for example 1, my expression is m squared plus 7 minus 4m squared. Remember that's 1m squared. So I'm going to look for my like terms. I have 1m squared minus 4m squared. When I do 1, take away 4, that's negative 3, and I leave it as m squared. Then the plus 7, there are no other constants to combine it with, so I write plus 7, and that is my final expression. Example 2, we have 2p plus 2 plus 5p minus 4. So I've got a couple different types of terms. I have 2p plus 5p, combine that together, and that's 7p. And then I have plus 2 minus 4. Watch the sign there. When I do positive 2, take away 4, I end up with negative 2. These are not like terms. They don't both have a p. This is 7p, and this is a constant of negative 2. So that's my final expression. Example 3, I have 3x minus 5 minus x minus 7. Remember that's 1x. So I'm going to combine my like terms. I have 3x minus 1x, which that's 2x. And then I have negative 5 minus 7, which is negative 12. My final expression then is 2x minus 12. And last one, example 4. This has quite a few terms, so we're going to make sure we don't combine the wrong things here. We have 2x to the third plus 4x minus 2x squared plus 3x plus 7x to the third. So 2x to the third plus 7x to the third. Those are both x to the thirds, same variable, same exponent. That leaves me with 9x to the thirds. Then I'm going to look for the next highest exponent, which I have negative 2x squared. I don't have any other x squared, so I can't combine it. So for my expression, I'm going to write minus 2x squared next. And then my last two terms, I have plus 4x plus 3x. Those are the like terms. They both have an x with an exponent of 1. I have 4x plus 3x, which is 7x. And that is the final expression. Okay, now we're going to fill out one more flap on your flip chart. So it's the third flap with the adding and subtracting exponents, and this will finish off the lesson. So it says, when adding or subtracting expressions with exponents, you simply combine like terms. This is super important because we're going to add on more properties, and you might get them kind of confused. Notice, no exponents change when you're adding and subtracting. So if there's a plus in the expression, your exponent is not going to change because you're just adding or subtracting it. I should have said plus or minus. So for the first example, we have 9x to the third plus 3x to the third plus 2x to the third. Notice these are all x to the third, so they are all like terms. So I'm going to look at the coefficients. 9 plus 3 is 12, plus 2 more is 14. And then I have x to the thirds. My exponent did not change to be a 9 or something else that you're multiplying, so it stayed x to the third. Next one, I have 4x to the fifth minus 2x to the fifth. Those are like terms because they're both x to the fifths. So I have 4x to the fifth minus 2x to the fifth. 4 minus 2, the coefficients, is just 2, and I'll leave it as x to the fifth. Now last one, I have some different terms in here. So I have 5x squared plus 4x plus 3 minus 3x squared plus 5. So looking at my like terms, I have 5x squared minus 3x squared. Well, if I look at 5 minus 3, that would be 2, and it's x to the second power. Then I have plus 4x. There are no other just x's. So I'm going to add that on my expression, plus 4x. And then my last one is my constants. I have plus 3 plus 5. So 3 plus 5 is 8. So that is my final expression.